everyone. Today my topic is recognition and analysis of facial attractiveness according to evaluator. As a table of contents, I will present 3 research papers. The first paper title is Filter Beauty in Oslo and Tokyo, a special preference analysis of facial attractiveness. We often perceive other people's face as beautiful. It is elemental of our sense of facial beauty that seem to be based on biological grounds or as universal learning experiments which may therefore be expressed cross-culturally as standard of beauty. A lingering question for research on facial aesthetics is what kind of beauty visual information underlying facial attractiveness decisions. The application of visual theory within psychology and neuroscience to visual information processing has revolutionized theoretical thinking at least since the previous century by allowing the encoding of stimulus pattern as composed of multiple levels of spatial frequency SF. In general, low LSF images carry more global and coarse information. When viewed alone, this may reveal the global shapes, physical asset of face, possibly better than high SF past HSF imaging. Exploring whether specific SF bands affect in a general specific manner the judgment of beauty may also throw light on sex dimensional cues to beautiful. Since this may not equally visible at a level of spatial frequency. This study focuses on the role of SF in facial aesthetics and presents a way to assess the relative weight of specific band of frequency information in beauty decisions. They recruited 52 students at the University of Oslo in Norway. 42 participants recruited among students at SNUSD University in Japan. Each face image was centered using Photoshop on light gray circle background in Figure 1. Finally, it created center fixed image for each pair of both filtered and broadband face, consisting of a black cross that was centered on gray blank screen. The experiment took place for the European participants at University of Oslo and for the Asian participants at SNUSD University. A session lasted approximately 1 hour. The procedure of both Norwegian and Japanese tasting session was identical. Participants press the left or right key on keyboards to indicate which of two faces they found most attractive. participants saw 160 pairs of filtered images of same-sex face. The first 10 trials show female pairs and then 10 male pairs, repeating this cycle 8 times. As shown in Figure 3, the mean proportion of time participant group selected the same face as the most attractive were highest for the medium lower fast filter face, while the mean proportion for male face were comparable for both Norwegian and Japanese participants. The Norwegian show higher correspondence between border band and filter condition for female face than Japanese participants. In Figure 4, dwell time of gaze on the attractive female face increased with spherical frequency, whereas dwell time peaked for the attractive male face at SF2 and for the relatively unattractive male face at SF3. For each face, we identify 6-day facial landmarks based on the delivery and added 6-day points relative to landmarks to increase the precision of the mapping. As in Figure 6, which show mean of the time of gaze when viewing the filtered face, participants fixate the nose most of the time. Such fixation on nose decrease with increasing SF, whereas fixation on eyes, which were the second most focused part of face, increase with increasing SF and more for the female than male face. Observers directly gaze more to the brows and the nasal root in the LSF than HSF face, but other face regions did not show much SF-dependent change in dwell time. In Figure 7, we illustrate the interactive effect of location with spherical frequency and face gender expressed as mean dwell time attend maps, showing significant difference in rate of fixation on the nose, upper lip, and mouth. In use on non-parametric permutation approach with threshold-free cluster enhanced to compare female and male models. It found for significant cluster of high similarity. First, in the area around the brows, nasal root, and eyes for male face. Second, in the area around the nose and cheek for female face. Third, around the upper lip and mouth for female face. Fourth, in the cheekbone for male face. A visual intersection of this graphic representation in Figure 11 reveal how attractiveness rating most related for both female and male face to internal picture of face like the eyebrows, eye, mouth, as well as lower part of face count or chin and their immediately surrounding facial surface regions. Note that for the female face, the eye region as well as of the lower portion of nose and the fullness of lips are clearly visible within this attractiveness correlative spherical frequencies. The conclusion of the first paper is as follows. This study revealed that the highest mean proportion of frequency for the most attractive face in pair occurred with highest frequency band for female face and medium low frequency band for male face. Thus, the most relevant information for judging male face attractiveness is within the low spherical frequencies, while the most relevant information for deciding upon female face beauty within the high spherical frequencies. As we all know, facial attractiveness play a vital role in daily social interactions. The technical advance of three-dimensional stereophotogrammetry open up new territory on facial soft tissue analysis. This study aim is to first find out visual way relying on the average face to describe the soft tissue characteristics of attractive Chinese Han population in three dimensions. Second, assess there is a discrepancy between genders. Third, different inclination exists between the Chinese and Indian evaluator when judging facial attractive. 410 individuals, including 242 females and 168 males, were recruited in this study. The inclusion criteria as follows. Chinese Han people in good general health aged between the age of 18 and 32 years. Several images would be taken until a clear facial surface with no hole or fissure was achieved. In addition, all subjects were not allowed to make up the day they are captured. The facial surface of 410 samples were divided into 14 groups randomly, from 28 to 32 in each. 8 Chinese and 9 Indian were invited as two panels to assess the attractiveness of each sample based on their first impressions. The assessing procedure was reliant on the bus from 1 to 10. Chinese and Indian is that for average face share were constructed to represent the most attractive facial morphology from the view of the above two evaluation groups. The average size of men and women was composed. Four panel of groups were analyzed: AMCG versus AMIG, AMCG versus AFCG, AFCG versus AFIG, AMIG versus AFIGs. In this study for purpose of find the proportion rules in these four average facial shares in portrait of 20 softest landmarks in the three-dimensional ordinate system, 70 linear measurements and 13 curve measurements were carried out by the 3D MD face system. Four average faces were constructed as shown in Figure 4 and Figure 5. Both male and female face show infant-like shapes. Attractive men were adapted to have a tall and straight bridge of nose and polygonous chin, while attractive women tend to manifest an infant-like character, which includes pump chip, fertile mouth, and nose. Moreover, women had more protrusive eyelids than men. Chinese evaluator attractive women showed thicker morphology than attractive men, while in Indian evaluator's viewpoint, women shared similar lip pupils with men. Indian evaluator inclined to prefer delicate nose with lower nose ridge but a protrusive lower lips. The attractive male and female that Indian evaluator prefer both had a prominent upper and lower lip but a higher nasal prominence. It is the result of height and width perspective of face of Indian and Chinese. When it comes to facial height analyzed in Indian opinions, both beautiful male and female had shorter total facial height but a longer lower facial height than Chinese evaluator preferred. In the aspect of facial width analysis, the parameter of facial width showed that Indian value male with wider face and female having slender face more highly. Nevertheless, both charming males and females had smaller lower facial width. The conclusion of the second study were summarized as follows. Discrepancy of aesthetic preference towards Chinese population exists between Chinese and Indians, especially centered on the area of upper and lower lip and nasal lip. Obvious differences were not found among the chin regions. Attractive males tend to exhibit a wider, longer face, but narrow geometric zone along with a mild thicker upper and lower lip and protrusive nose and chin compared to females. The title of the paper in part 3 is Effect of Dental and Background Facial Attractiveness on Facial Attractiveness and Perceived Integrity and Social and Intellectual Qualities. The significance of dental attractiveness on facial attractiveness remain uncertain, but there is a significant role that dental appearance play in determining our first impressions. The aims of this investigation were to assess the role of quantified dental attractiveness on facial attractiveness and to evaluate how different levels of quality facial and dental attractiveness of model influence letters of opinion of their social attractiveness. Participants were recruited 65 people. They were between 18 and 30 years old and Caucasian. Figure 1 examines the influence of dental attractiveness on facial attractiveness for female individuals of the three different levels of background facial attractiveness: unattractiveness, average, and attractive unless the teeth were near ideal. They have neutral or negative effect on the background attractiveness. Generally, for female individuals, the greatest effect was pre-dental aesthetic for attractive models. Figure 2 shows the influence of dental attractiveness on background attractiveness for male. Among male individuals, an attractive face suffered less from decline than dental aesthetics, whereas attractive and average face suffer more. For question Figure 5 and Figure 6 show the influence of dental attractiveness on integrity and social and intellectual attractiveness for each sex and background facial attractiveness level. For women, the cluster generally had higher overall rating as models' background facial attractiveness increased, occupying the 38 to 78 bus ranges. As the background facial attractiveness increased, the impact of dental aesthetic on judgment became less important. For men, the teeth had more effect as background facial attractiveness increased It was opposite for women. The dimension of social attractiveness were significantly affected by dentition at same level of background facial attractiveness. The conclusion of third study are summarized as follows. First, for both men and women, rural dental aesthetic had a greater effect on more attractiveness face. Second, the impact of dental attractiveness on background facial attractiveness and social integrity and intellectual attractiveness was dependent on dental attractiveness level, background facial attractiveness, and model sex. Third, judgment about integrity, social ability, and intelligence were strongly affected by dental aesthetics. These effects were more consistent for male face. Thank you for listening.